Hello, everybody. Yeah, we have slides. So before getting started, I just want to tell you that the slides are already online, so you can get them by scanning this QR code or just going to this URL right there. And the reason for this is that I will show you some examples. So there is some code, there are some things that maybe you want to spend a bit more time looking at, or maybe just after the talk, maybe you want to go back and check a few things. So I think it's useful if you have a look. So while you scan this, I'm just going to say thank you to everybody for coming here today. Thank you to the organizer for inviting me. So yeah, I hope you are going to be satisfied with this talk at the end. So who is this guy in front of you? Hi, everyone. I'm Luciano. I work in Dublin, even though you might have guessed by my funny accent and my name that I am Italian. I work for Vectra, which is a very interesting company. They work in the intersection between machine learning and security, so they do threat detection in real time. So if you are interested in this space, please come and talk to me after the talk. And there are 3 side projects that I'm very proud about. I've been working on them with amazing people over the last 2.5 years. The first one is a book on Node.JS and design patterns. Another one is Full Stack Bulletin, which is a newsletter for full stack developers. And then there is Serverless Lab, which is an open source course to learn serverless on AWS. So what are we going to talk today is based on some work that I've been doing before, and as part of the book that I mentioned before, and 2 articles that I wrote for Rising Stack. So at the end of this talk, if something is not clear, maybe you can go there and check these links, because probably there is a lot more detail in there, and it can be useful for you if you're interested in this topic. Okay, what are we going to discuss today? This is the agenda. First, we're going to try to understand what JWT or JSON Web Token actually is and how it works. And then we are going to do some little testing, like we are going to try to reverse engineer a token, and then we're going to try to start from scratch and build a new token. And finally, we are going to try to understand what are the security boundaries of JWT tokens and how we can actually brute force a token, and then what can we do with that. So let's start with a very, very nice definition from the RFC of JWT token. So JSON Web Token is a compact URL-safe means of representing claims to be transferred between 2 parties. The claims in a JWT are encoded in JSON and chicken, right? Yeah, I guess. This is a bit boring. Let's try another approach. Simpler, right? Well, yeah, maybe not. Okay, I'm going to try to give you my personal definition of JWT. So JWT is a URL-safe, stateless protocol for transferring claims. I guess this is much simpler, but maybe you're wondering, what does URL-safe means? What does stateless means? What does claim means? So we're going to try to explore all these words together so that it's very clear what they mean. So URL safe basically means that the token, which is just a string, it's using characters that can be safely used as part of a URL, which basically means that we will never see in a JWT token characters that are common URL separators like equal, slash, or question marks. So as you can see in this example here, you can put a token in there, and you don't need to do any special encoding. What stateless means? Basically means that when you have this string, this token, most often you want to know if the token is valid in the context of an application. And in order to do that with other approach, when you are not using JWT, most often you need to have a database where you store all the generated tokens. JWT is a bit special in this sense because it doesn't need to have a database of tokens. All the information is self-contained, so people like to call it a stateless token. And then finally, what is a claim? Well, claim is, in general, some information that you want to transfer between 2 parties. And just to give you a few examples, it might be an information about identity. So for example, you say, this token is telling that the current user is user X, or maybe it can be authorization information. So you can say in the token that a user X is authorized to perform a specific action in the application. Or it can be, for example, ownership, like some user add a ticket, for example, for a concert, and the token describes the user can go to this concert at a given moment in time. So this is just generic information, but there you can also embed as claims inside the token validity constraints. So things like, okay, don't use this token before a certain timestamp or after a certain timestamp, or don't use this token outside a given audience, which can represent, for example, an ID of an application, or don't use this token if the user is not a given user. But there are also other claims which are very generic things that represents the protocol information of the JWT token we are using, like the type of token, all the algorithm that we are using to create the signature, which is something we are going to see in a moment. So in general, when we say that JWT tokens as claims, we refer to all the bits of information that are stored within the token. So let's go back here, this very cryptic thing, and let's try to understand it better. So if you notice very carefully, there were dots in there, which basically are separators for the three parts that constitute a JWT token. So let's try to understand what are these three parts. So the first part is an header, the second part is a payload, and the third part is a signature. So you probably noticed that the characters here are something you might have seen on the web. And actually, in the previous presentation, there was a mention of base64. And you can see that this kind of characters can remind you about base64 encoding. And this is actually true. Like, we are using base64. In particular, the header and the payload of a JWT token are using a variation of base64 that is called base64 URL that basically just replaces all these characters that might be a bit dangerous to use in a URL with some characters that are fine to be used in a URL. For example, the equals are replaced with something else that you can actually use in a URL. So you know that base64 is something we can easily encode and decode. So let's try to see what happens if we decode the header and the payload from this example. So let's take the header. It looks like this. So if we apply base64 URL decode, that's what we get. Then let's do the same for the payload, and that's what we get. So basically, you can see that the information contained within a token is just JSON data, right? Let's try to understand it even better. So the header is telling us ALG, which is the kind of algorithm that we are using in this token, and then we have a generic type which says this token is a JWT token. Regarding ALG, we have a number of different algorithms. The most common are these three that I have here. The first one is HS256, which is basically using the SHA-256 that Ernie showed you before. So thank you for that introduction. And it's basically an hashing that is based on a synchronous key. And that's the one where we will focus most today. But there is another interesting one that is using public and private key hashing. Then there is another very infamous one, which is called known. And I really encourage you to read the history of this one. And this was the cause of a very, very severe bug in many websites. So I really encourage you to later on click on this link on the word infamous and read the full story. This is actually deprecated. You cannot use it anymore. So let's go back to our payload. And again, it's just JSON. And can be anything. So you can actually encode anything you want inside a JWT token. So it's up to you. It's up to what you want to build with your application to decide what kind of information do you want to store in there. But again, there are some claims that are considered kind of registered or standard. Many libraries will already give you facilities to integrate these claims inside your tokens. And the most famous one are issuer, which represents the authority that is generated the token, like can be Auth0 if you're using Auth0 as an identity provider. Then there is subject, which is generally the person or the system for which you are generating a token, and can be an email, let's say, or an ID, or whatever makes sense for you to identify an entity. And then we have audience, expiration time, don't use before, or the time when the token was created. And this is how it will look if you encode them as a JSON. So, okay, so far it's just metadata. So this is just a format that allows us to store this metadata in a way that can be easily encoded and decoded. But why should we use this for security? What makes this metadata safe? And that's the signature. What is the signature then? Well, the signature is again a string that is base64 URL encoded, and it's a cryptographic signature of the header and the payload. Let's see how this actually works and how we can construct the signature. So there is a very simple formula. So we use, again, this SH256 hashing algorithm where basically we take the header, we apply the base64 URL encode, then we concatenate that with the base64 URL encode for the payload, separating them with a dot. And we pass all of this as the first parameter. So you see all of this here is the first parameter to the hashing function. And then we also pass as another parameter this secret here. So be very careful, because secret here is the important part of this algorithm. So basically we take header, payload, and a secret, and we can build a signature. So why the secret is so important? Because if a system knows the secret at any given moment in time, then it will be able to validate and build every token in the context of this application. So now let's try to create a token from scratch. So we did this exercise where basically we started from an existing token and we try to reverse engineer what is the content of a token and how a token looks like. Now let's start from scratch and let's say we want to build a new token right now. So I wanted to do a live demo, but I figured out it was taking too long, so I'm going to cheat a little bit. I hope it's readable. So basically, here we are importing two libraries. This one allows us to do base64 URL encoding and decoding. This one is a common Node.js library that allows us to do crypto operation like calculating the SH256. So the first thing we do is basically creating the header, which is pretty standard. So we want to use this algorithm, and it's a JWT token. We create a JSON object, we stringify it, and then we base64 URL encode it. So this gives us the header, which is going to look something like this. Then we create the payload, and we just want to create a JWT token that contains as a claim hello Oslo, right? This is just an example. So again, we create the JSON object, message, string on it, we stringify it, and then we apply base64 URL encode, which gives us something like that as well. So at this point, we know already that the content is just the concatenation of header and payload with a dot in between. So if we print this, this is how our content of the token is going to look like. Now let's come to the important part. How do we sign this token, right? So we have to decide a secret. Well, it's not really a secret right now because I'm sharing it with all of you, but let's pretend nobody else knows that. And the secret for us is we are web rebels. How do we sign the content with this secret? So we have to use a bunch of functions. So if you use Node.js using crypto, you can use this .create_h_mac hashing function, passing the SHA-256 and our secret. Then this is the way that you pass something that you want to calculate the hash. And then you can calculate this hash as base64. Be careful that this is not base64 URL. So we need to use this other function to normalize it for JWT tokens. So at this point, we have a signature that is going to look like this. So yeah, that's basically the end of it, but where basically we have the three parts, and this is our actual token, right? But of course, we are humans, and this doesn't mean anything to us, right? So I'm going to show you a nice tool built by OutZero that allows us to basically debug JWT tokens. So if you go to this website, which is at jwt.io, you can basically paste in a token. There is an example one that just says chicken, chicken, chicken. So I pasted the new one, and basically you can see that what is the algorithm, what is the type of token, what is the message. And if you know what's the secret, you can also validate that. So at the moment it's saying invalidate signature because it's testing the token against some secret, which is not our secret. Okay? So let's go back to the slides. So I show you JWT.io. Now let's try to understand when to use JWT tokens, why they are useful. So let's make an example. And one of the most common examples is session tokens. And I'm going to show you the difference between a classic implementation where we use cookies and a session storage, and compare that with using just JWT tokens. So when we use cookies, we generally have three systems in place, three different components. The first one is the browser for the users, then we have a web server, and then we have a session database. So the flow of data is generally like this. There is a post to a login page, we receive a username and password to a server, and then the server will need to validate the username and password and check if they are the right ones. And if it's happy with that, it's going to generate a session for this user. And a session generally is just a random string that is stored on a database table. And it is associated with the name or the username for this user. So once this is stored, the ID of the session is returned to the browser in the form of a cookie. So from this moment on, every time there is a new request coming in from the browser, the cookie will be attached with the session ID, and the server will be able to fetch the session again. So it's going to do another query to the session storage with this ID, and it's going to try to fetch, is there a session for this ID? What is the user? And it's going to figure out the user is Luciano, and then it's going to be able to generate a page only for Luciano. So let's see how this looks like with JWT instead. We have only two components, a browser and a server. So there is, again, a login attempt. This time, the server, once it's happy with the username and password, doesn't need to go somewhere else, because it can create in place a JWT token, where basically we are going to store that this token is being created for the user Luciano, and then it's going to be signed with a secret that only the server knows. That's something that can be immediately returned back to the browser. It can be, again, a cookie, or it can be a header, or something that can get stored in the local storage. This is most often what happens if you are doing a single-page application. Instead of using cookies, people prefer to use local storage. But it doesn't really matter. Like, there is a string, and we are passing it back to the browser. And the string is just saying, inside the token, the subject for this token is Luciano. The next time there is a request from the browser, for example, to go to the profile page, the token is attached, let's say, in the form of an header, in this case. And so when the server receives the request, it can verify, OK, I received a token in the, let's say, authorization header. This token says that this is for Luciano. The signature is OK. So I'm pretty sure that this is a valid authentication attempt. I can consider the request coming from Luciano. So I can immediately generate back the page for Luciano. Notice that only the server will know the secret in all this flow. It's never shared with the browser in any way or form. So let's check some differences between cookie session and JWT token. So in the cookie session approach, we need a database to store the session data. Then the database is queried every single time that there is a request in order to fetch back the session. And the session is identified with just an ID, so which can be a random string. And this is the only information shared every time the browser is asking something to the server. So no data is actually attached into this token that gets exchanged every time. And the other important property is that sessions can be invalidated at any moment in time. So you can just go into the session database and delete or mark the session as expired or invalid. With JWT token, we saw we don't need a session database because the server can do everything and the information is contained already inside the token. So for every request, the token is passed over and it's verified by the server, and all the data will be inside it. But there is a problem that if you want to invalidate tokens, there is no easy way to do that with JWT. You will need to have to build something like a blacklist of invalidated tokens. So it's a bit up to you, but the suggestion there is to have expiry flags. So after a while, the token is going to expire anyway. Another very interesting JWT use case is if you want to create, for example, password reset links. There is an amazing article that describes you how to do that with JWT. And if you have to do it with a database, it's a bit painful. So with JWT, it becomes much easier. So if you are interested, you can have a look at the link there. So, okay, so far we know how JWT work. We can create them. If we have one, we understand how to read that. And it looks cool. I mean, it's solving us a lot of problems in the examples I showed you. But of course, there are pitfalls, right? Nothing is perfect in this world. And the first pitfall, I already mentioned that briefly, is that the data is public. So once you have a token, you can just paste it into JWT.io, and you will see everything that is in there. So, of course, don't store in there anything sensible like the user password or credit card information or things like that, right? And then the second issue is that there is no token database. So let's say for a moment that somebody can forge a token and send it to the server. I guess there is no way that the server can tell, is this really a token that I generated before or somebody else generated it for me? So you can start to think about evil things you can do with that. And actually, I wanted to show you a demo about this. So let's go to this page. Okay. So we have this amazing website, Merlin Online Spellbook, where basically you can manage your spells online, right? But you need a login for that. So let's try to log in. Okay, I logged in as a user. I am Luciano there in the system, but the system is telling me, yeah, you are just a normal user. I mean, I'm not going to give you any spell. You are there, you see a nice page, but that's all you can do, right? Okay, I'm fine with that. But at some point, I start to notice that there is this weird URL. I don't know if you can read it. But basically, at this point, you should notice that there is something that is like, OK, the session ID is something that looks like a JWT token. So let's take this one, and let's check inside JWT.io how it looks like. Cool. So we can actually see what's inside the token. We can see it's a JWT token using the synchronous hashing algorithm. And the subject, so the user is Luciano, the role is just normal user, and then there is a generation timestamp. So, okay, now I am a bit curious to see what happens if I just change this to admin. You see here I'm getting a new token, and I want to go back here and replace this guy. Oops. Well, the system is smart enough to tell me that this session token is invalid. So what do you think I did wrong? Like, why the system is so smart to figure it out that, yeah, right? So we didn't have any way to generate a proper signature for this new token, right? So when I just changed here to admin, the system here is just using this random secret, which is probably different from what the server is using right now. So we are signing this token with something that is not the right secret. That's why the server can figure it out is the wrong one. We are going to go back here in a moment. Oops. OK, so we say that if you have a token, there is a secret, and with this secret, you can either sign a new token or validate if the current token is valid or not. So what if we, given this token that we got the first time when we were just a simple user, what if we try to guess the token, right? How difficult can it be? Well, yeah, we can do that, but we need to build tools for that. And we can build a distributed JWT token. And this is going to be the second part of this talk. But before actually going into the detail, I already built this, and it's available online. So I want to show you how it looks like if you just want to use it. And we are going to start to use it in the background while we move on to the next part. So this is the tool. As a distributed system, you have a client and a server. So the server, you can access that with this command, JWT Cracker server. And it's going to give you a nice help if you want. So basically, the way you use it, you just invoke JWT Cracker server, and you can pass a token. And this is going to initialize the server for cracking this specific token. If you just want to use the client, it's the same thing. So you just put here client, and it's going to give you the usage. So you just need to pass the connection information to reach into a specific server. And the server is going to tell you what to do in order to try to crack this token. So now what we want to do is to run the server with the token that we got the first time that we logged in. So when we were just a normal user, which we know is a valid token, which I should have here somewhere. Yeah, I think it's this one. I am cheating here a little bit. So one of the options of the server is to specify a given alphabet. This is just to make the brute force attempt faster, just because I know that the password is going to contain only these characters. In reality, you can use bigger alphabets, like by default you have from A to Z and all the numbers, lowercase, uppercase. But it's going to take a few hours to crack this specific token. So here I'm taking a little shortcut just because I know it's going to work. So at this point, the server is started. It's not going to do anything. It's just going to wait for connections. And here in my local machine, I can spin up 4 clients in 4 different processes. This is, of course, only my local machine. But if any of you would have the client, I can just give you my IP, and you can contribute in trying to crack this token. So let's start this. And you can see it's going to do some work. We are going to get back later into this. And hopefully, if we are lucky, we are going to have the password before the end of the presentation. OK, so at this point, we know what's the idea. We found a valid token because we were able to log in, and we are trying to guess this secret with a brute force attack. So the idea of this brute force attack is that the system is going to try any possible password over the alphabet we specified. And if one of these passwords, one of these secrets is going to be validating the token, then we found the actual secret. And when we have that, we can actually build our own tokens. And the application is not going to be able to distinguish between the ones that were actually generated by the server and the one we are generating ourselves. So we need some magic weapons for this tool. We need Node.js, 0enqueue, and JSON Web Token module. So if you never heard of 0enqueue, it's a very nice open source library that allows you to do networking stuff, and it's also a concurrency framework. But now let's spend some time to figure out what is really the brute force problem. What is the thing we are trying to do, right? It's a very interesting problem because of this property. It has a virtually infinite solution space, which basically means, like in our case, that we want to try all the possible strings over an alphabet. But you know that a string can be of any length, can be, in theory, infinitely long, right? So if we are really using a long secret, then it's going to take a long time in order to try all the possible combinations. But yeah, the main idea is that we need to establish an order between all the possible strings. So what is common to do in these cases is that you establish a relationship one-to-one from the set of natural numbers, so integers, to strings over a given alphabet. So in this example, we have an alphabet of A and B. And we are saying that if we want to establish a relationship between numbers and strings over this alphabet, we can use this property where 0 is the empty string, then we start with A because it's the first one in the alphabet, then we use B, and then we start to say AA, AB, BA, BB. You get the idea. So with this approach, we can build all the strings over this alphabet. And what is nice is that you can associate a natural number to a given string in this alphabet, and it's going to be a unique pair. So we said again that this application we are building is distributed, so we have a server and a number of clients. The role of the server is just to initialize the context with a given JWT token and a given alphabet, and then to coordinate the work of all the clients. So the clients will know what to do in order to verify if a token is matching a given secret, and they will receive all the information from the server that is coordinating the work between all the different clients. We are going to use some specific network patterns that are available in 0enqueue to coordinate this message exchange. And we have 2 different types of messages. The first one is basically the messages that we need to coordinate the work. And the second one is just an exit signal that is sent to everybody when some client found the actual secret. So for the first case, the conversation is basically one-to-one. So there is a channel between the server and every single client, and it's a separate channel. So for this, we can use a pattern that is called router-dealer in ZeroMQ, and it's basically like a request response where the server is sending some information to the client, and it needs to wait the client to send an answer back before it can send another piece of information. And this allows us to coordinate all the exchange and all the brute force attempts. And then, of course, if some of this client will say, OK, I found the secret, then there is a signal of termination that is just broadcasted using the pub/sub pattern to all the clients. So how can we represent the server state? So we know the server is the one that knows what's the current status of processing all these possible strings. Well, the first thing that we can think of is that this solution space is kind of ordered once we establish this relationship between numbers and strings. So we can divide that into chunks. For example, let's say that we define that our chunks are of size 3. So we will have the first chunk that goes from 0 to 2, then 3 to 5, then 6 to 8, and so on. So the initial server state can be represented as this. There is a cursor that starts from 0, and there is an empty map for clients. So at some point, a client is connecting to the server, and it will receive the first batch to be processed. So it basically just receives something that it's saying, OK, you have to start from 0, and you have to go up to 2. And the state is updated immediately. So now the cursor is pointing to 3, which indicates the next batch. And then there is a client connected. So the server is keeping track of all the clients that connect at any given moment in time. And as soon as they connect, they will receive the first job. So in this current state, we have 3 clients, and they are doing they are analyzing different parts of the solution space. At some point, one of these clients is going to finish to process its batch. It's not going to be successful, so it's going to request for a new batch. So the state is updated, and the system is going to keep track of what is the work that every client is doing, and what is the next piece of solution space to explore. So let's see a bit of code. How can you implement that in Node.js and ZeroMQ? So this is very simple. So here we have the state, the initial state, so cursor 0, and then an empty map for the clients. And then we have 2 functions, add client and assign next batch. Add client is basically the function that is invoked every time that there is a successful connection in ZeroMQ from a client to the server. And it's basically storing some information. It's storing the channel ID, the ZeroMQ channel between the server and the client. And then it's going to store this ID into an object, what is the channel, and then a timestamp to take into account when this client joined the cluster. And then it's going to be called assign next batch function for this client, where basically the batch that this client will need to start process is passed to the actual client. So here we are basically calculating what is the next batch using the cursor, and then we are sending this information back to the client. So the message flow is going to look a bit like this. A client joined the server is going to tell the client, OK, this is the token we are trying to crack, this is the alphabet, and this is the first batch you have to analyze. And then the client starts to analyze, it's not successful, so it's going to request a next batch. The next batch is passed back, and it's just the information. OK, start from this index and go to this other index. And this step 3 and 4 can go on forever until the client will figure it out what is the secret. And it's going to say, OK, success, this is the secret I found. So we can implement this flow here, and we have server and client implementation. It's not particularly complex, so I'm not going to spend much time. You can see here that a message is exchanged, and every message has a type, and based on the type, you can do different things. Like if it's join, this is the code that will handle the join message. This is the next message, and this is the success message. So here we are basically dispatching all the information for the first batch, here for the next batch, and here we are just broadcasting the signal of success. Very simple as well in the client side. So we have based on the message, we will have different things we can do. So for example, when it starts, we're going to invoke the start function, which is going to start to process the different batches. And yeah, that's very easy, and I don't want to go too much into detail. But what is important, and we will see the last bit of code about this, is how the client is trying to crack a single token for a single batch. So we saw that what the client received is just this 3 to 6, for example, which if we have an alphabet of A and B, is going to mean that this client will need to try to crack AA, AB, BA, and BB. So the client is going to start a loop where it's going to build all the string from the numbers, and then it's going to try one by one to see if the string validates the token. So this is the part that implements that, and it's very simple, but the reason why it's simple is because we are using this library here, indexed string variation, which basically allows us to, given an alphabet and an integer, to build the string that is actually representing that number over the given alphabet. And then there is just a loop where basically from the initial part of the batch to the end of the batch, we get the current variation for the index, and then we try to verify the token using the JSON Web Token library. So you can see we pass here the current secret. Here it's called password, but this is actually the secret we are trying to crack. I think this is actually a typo because here is secret and here is password, but yeah, I will fix this. And then the important part is that we are ignoring expiration and not before, because we might have a token that was valid, but now it's expired, but we don't care about that. We just want to check if the signature matches the token itself. And of course, we can have two cases, which is if this doesn't fail, we have a try catch. If this fails, it's going to throw an exception. So if it fails, we just ignore the error and continue the loop. If it doesn't fail, it means that the secret was actually the valid one, so we can just return it. So let's go back to our demo. I think we were lucky, yeah. So we have a password here, and the secret is rebel. So just to see what was happening here, so we started our server, and our server was waiting for connection. At some point, there were 4 clients joining the server, and they got specific batches. Of course, here in real life, you will have bigger batches, not just a batch of size 3. So they will start to, client 1 will start to explore this solution space, and all the other clients will have a different solution space. And you can see here on the right-hand side that we have the work for every client. And the client will respond back, for example, in this case, OK, I didn't find any, what was the secret in this batch, so give me a new one. Until one of them actually found the secret and communicated back to the server. So the server is sending the exit signal to all the other ones. So you can see here that client number 1 actually found the password and just communicated it back and stopped, while the others just received an exit signal here. So OK, now that we have this password, this secret here, rebel, we can go back to our JWT, and we can say, OK, now I know that the secret is rebel. So when we change something, the system is, JWT.io is going to assign again the token. So let's see if now we are luckier. So we can go back here and change this session. Woohoo, works. So now we are an admin. And as an admin, we have access to powerful spells. Let's see what we can do. Yeah. Of course, in real life, you would expect to find, I don't know, credit card numbers or passwords or stuff like that. So be careful about these things. So just to close this off, you might wonder, is JWT safe to use? I mean, you just cracked one is like in like, I don't know, 10 minutes. Well, definitely yes. It's heavily used in the industry by big players like AWS, by OutZero. It's also in some of the implementation of OAuth as a token exchange mechanism, like OpenID will use JWT heavily. So you can trust JWT itself. But of course, you have to be careful and use it wisely. So if you are using the synchronous hashing mechanism, like the one we used here, you have to be careful and be sure you are using a very strong and long secret, and that you keep this secret really secret. So keep it only where it needs to belong and don't copy it somewhere else. But there is an even better solution, is that you can use another algorithm, which is the RS-256, that uses a combination of public and private key. So it's much safer, and it's easier if you just want to validate the token. You don't need to have the private key because you can only use the public key. So the only concern there is that you will get much bigger tokens. So if the size of the payload is a concern, then maybe it's better to use the other algorithm. Okay, I had this question once while I was talking about this topic. Somebody asked me, what if I create a short-lived token? Because this is what happens in other systems when you are not using JWT. You can create tokens that expire after 5 minutes. So maybe you can think, okay, you cannot really crack it in 5 minutes, so I'm safe. Well, if you were careful before, I showed you that if you have a token that was valid at any given moment in time, you can still verify if the signature is like the right one. If you have the secret, then you can check, okay, now I have this token, I have full control, I can recreate the token, and where is the information for the expiry time? Inside the token. So once you have the secret, you can change the expiry time. So this is not a solution in this case. And this is because JWT is stateless. Then last question, should I be worried about brute force? Well, not really. I mean, it's not that easy as I showed you here. Like in a real life, it will take me, I don't know, maybe days, months, years. Or I will need to have such a huge compute power that I really need to be willing to break into this JWT. And I'm not going to do it for the Merlin spells webpage, of course. So yeah, as long as you know the basic rules of brute force and you know how to pick a solid secret and maybe do some secret rotation, then you are safe against brute force, I would say. So TLDR, just to close this off, JWT is cool, it's stateless. You can use it to transfer any claim, not just for session authentication, but also in other context. Just choose the right algorithm for your particular use case. If you are using a secret-based algorithm, try to keep it safe and pick a good secret. Don't disclose sensitive information inside the token, so no password, no credit card numbers, or other things like that. And then don't be worried about brute force as long as you understand how it works. That's it. Thank you very much.
Thank you. Okay, that was really awesome that you took us through what it is and how to brute force crack it. All right, so one of the questions you touched on at the end, which was avoiding attacks in the future, such as long secrets and things like that. Mm-hmm. So you touched on that, unless there's anything else you want to add about.
So you mean like
avoiding, brute force attacks?
Yeah. So well, I guess that brute force is something that you cannot really avoid it. Like it's something that if people are willing to do, they can still try to do. And specifically in this case, because like in other cases when you have, I don't know, kind of network-based brute force attacks, maybe you can just block the IP addresses, you can do other things. In this case, everything is happening outside your control. So as soon as the attacker has a token which was valid at a given moment in time, they can move the token somewhere else you don't even know, and they can start to brute force that, because the goal is just to break something like a string and figure out what was the secret that can create the same signature for that token. So yeah, I think the goal there, well, what you can do to defend yourself is only to pick a good secret, and maybe having blacklists of tokens can help you somehow, but it's not really, it defeats a bit the purpose of JWT because it's not going to make it stateless anymore. So yeah, I will just say to you, try to use long enough and complex enough, so with all the possible characters, secrets. And also, if you don't have any space constraint in the token, use the other algorithm, which is much safer because it uses a combination of public and private key. So it's much, much harder that people are going to try to use brute force over that.
All right, also related to the safety, since the JavaScript has access to it, given what is stored in what is stored is the user's identity, I guess, keeping it secure on the client side.
Yeah, so there is like a trade-off again. Like, what I will say is that you can do things like, okay, re-encrypt the content of the token. Like, I've seen that happening, which again is a bit defeating the purpose of JWT, because JWT is meant to be a simple protocol. So if you start to add things on top, then you have to deal with that and build your own implementation of libraries and stuff. So what I would suggest is to store only the minimal information. And for example, when you are storing something that gives you the idea of a user, and I don't know, sometimes you might be tempted to store an email, right? To say, okay, this is the user that is actually logged in. But email might be considered a sensible information. So if somebody else is stealing your cookies or, I don't know, your local storage, they will see what's your email. So instead of doing that, you maybe can just use a random ID to represent the user. And of course, you will have to compare that with your own database. So there are trade-offs you can make, and most of the time you are trading, let's say, simplicity with security. But sometimes you can find nice spots to keep things simple and safe at the same time.
Okay, related to if you choose to base it on or include the user's email or something like the username, what happens if that gets updated, if the user changes that information?
Yeah, of course, the tokens, if the user has already the tokens that were generated before, they're not valid anymore because they will try to do stuff for a user that doesn't exist anymore. So probably there, what will happen, you have to define the business logic of your application, of course, but what will be sensible to do is probably to just reject the token and redirect the user to the login page again, where a new token is going to be generated with the proper username.
Okay, great. All right, and lastly, did you draw the unicorns?
Unfortunately, no, I'm not that good. Actually, I had an extra slide at the end where you can find all the resources where I took inspiration, and there is a website with all these nice graphics, and they are free to use. So maybe it's an idea for another presentation if you want to.
Awesome. Thank you so much.
Thanks to you. Thank you, everybody. Thank you.